Hello, everyone, and welcome to our session today titled Last Mile Infrastructure for AI, where the inference runs a distributed architecture. Really looking forward to a great panel session today. We're going to be trying to cover a little bit of the AI market context, a little bit of business drivers towards investment in last mile infrastructure and edge computing infrastructure in relation to this AI boom we're having at the moment, and what those infrastructure upgrades could look like across access networks, across data center interconnects, and across metro and edge compute as well. I'm delighted to be joined by an excellent panel who I'll ask to introduce themselves. Before we do that, just a quick introduction from me. My name's Joe. I'm a principal consultant and I lead the data center practice at STL Partners. We're a strategy consulting firm based in London, and I lead our work on strategic projects with the data center ecosystem. We've also got a wonderful panel, as I mentioned. We've got Majed, Nikhil, Stewart, and Tomek. And guys, if you could possibly introduce yourselves, maybe in that order, starting with Majed, that would be great.
Thank you, Joe. My name is Majed Amine. I work for Google, and I had what we call the Distributed Cloud Solutions, or GDC for short, Google Distributed Cloud, which is basically anything outside the big data centers. How do we push our capabilities in AI and other things all the way to the edge? And happy to be here today.
Great. And Nikhil?
Hello, everyone. I would start with an introduction. I'll say when we talk about edge inference, and that's what we are here for, most people think somewhat location. My background from shipping Wi-Fi devices to Apple, scale, building fail-safe connectivity at Tesla, and doing enterprise-level connectivity at Verizon now, I have framed this story in a momentum-building fashion. So this is not new, but I'm happy to talk more about how it's all going to be put together for the future.
Great. And Stewart?
Yeah, Stewart, head of PreSales at Vodafone for the Europe region. And I think it's going to be a really interesting session. As I said before the start, I've canvassed so many people internally at Vodafone and got so many different opinions. I'm not going to be able to share them all, but it's clearly a topic that resonates. So yeah, looking forward to the session.
Great. And last but very much not least, Tomek.
Yeah, hi, I'm Tomek Mackowiak. I'm the VP of Product for Colovore Data Centers, and we're just a specialty colo. We specialize in ultra high density liquid cooled data centers on the edge, and we target tier 1 markets in the United States. And we basically build for the enterprise and AI use cases with sub 10 millisecond latency in those deep concentrations of data gravity. So the major metros across the United States.
Great. So really diverse range of opinions, hopefully, for this panel. And maybe, Majed, you can get us started. What I'd love to do for the audience is give a bit of some of the definitions of the different types of AI workloads that are kind of in play. Obviously, hear a lot about training and inference in 2 large buckets, but within both of those. And maybe you could shed a little bit of light about some of the different types of AI workload and potentially also the different infrastructure requirements that those workloads have.
Absolutely. Well, I think to simplify, there's many dimensions, but to simplify for today's discussion, there are 2 main dimensions that are important. One is the sizing of the activity itself, meaning is it something that is requiring a huge infrastructure for training models and developing foundational models, and the other one, or basically what's closer to the user, where we call it inferencing from that perspective. So that's one dimension. How close is it to delivering a value to an end user versus being trained, etc. And then from the other dimension, it's more around how are you preparing the AI delivery. So there are steps where a model could be in a pre-training model or in a fine-tuning approach, or in a RAG training, meaning like it's retrieving augmented generation capabilities to be customized and specialized for other areas. So in a simple term, we as specialists look at the AI models as either from a training versus inferencing, And then from a learning perspective, we'll from pre-training models, which we call foundational, to fine-tuning, and then to delivering it to the end user. So every other subcategory comes within either that dimension or the other.
Nice. And Tomek, keen to hear your opinion, obviously from the co-location standpoint. You maybe don't necessarily have full visibility into what workloads exactly your tenants are running, but maybe what is the scope of different infrastructure requirements that different customers have, and how much does that vary across some of your different kind of customers and tenants? Well, I think you might be on mute still, Tomek.
There you go. Yeah. So great question. There's a fairly broad range. So we typically concern ourselves with inference workloads at this point for the enterprise. And if we think of it in terms of rack densities, they go at this point from about 20 kilowatts a rack up to 120 a rack, 140. So all that translates into basically different workloads, different model sizes. We deliver a lot of LLM-based services. So there is an entire ecosystem of models, different sizes, some open source, some provided by the larger providers on a tokenized type basis. So the variability is very high, but the one common thread across them all is that you really need high density infrastructure to deliver it. And we're not experts on the wireless side. We're basically the data center that's sitting at the last kind of step before inference is disseminated or absorbed and processed. So quite a large scale as far as what people are doing. People are running L40S infrastructure all the way up to B300 and soon GB300. And it's all dependent on really the workload. And of course, most enterprises use multimodal approaches to where basically have a workload router, and certain requests go to certain infrastructure, maybe smaller models that can answer things very quickly, or smaller models that exist within RAG infrastructure. So it's kind of all over the place, but all of it kind of goes beyond the scope of the regular air-cooled data center. So it's a great question. It's a hard one to answer. And I don't think I've done a very good job really breaking it down, but that's kind of more or less how we think of the situation currently.
Nice. And then maybe Nikhil or Stewart, if you guys could come in with more of the kind of telecoms and connectivity perspective, both on these different types of AI workload which we've spoken about, but any visibility you guys have into the different infrastructure requirements of different workloads, and maybe also starting to touch on some of the use cases which have slightly different infrastructure requirements from the kind of connectivity and telecom side.
I think thanks for pulling the connectivity space. I think the part where we describe that, or when we start questioning, it's becoming more and more common these days when we say, oh, where does inference run? Where does it exist? It's not a single point contention or a single point answer that anyone can describe. It's more about designing of how the inference will flow across the continuum. There are specific latency. There's a cost to it. There are government or governance constraints. There are policies that exist for that. The entire flow, where we used to describe it very simple, like cloud to device, has reshaped into cloud to the regional edge, the edge talking to on-prem, if on-prem is available, and then it's going to a device, and the devices are changing too. So the entire perspective of like having these big devices like laptops or the computers which had compute on them is changing to more smaller devices, wearables, glasses, coming in the future. And then they define the scope of where a lot of compute doesn't exist on the device itself. So connectivity in that spectrum becomes fairly important in a newer shape. What can Wi-Fi present? What can 5G present? What do we design in terms of being indoors versus mobility perspective going outdoors? How can we are describing some of these events in terms of telecom where some of the LLMs or some of the low model computes can exist on edge, and then there can be a better handling between the request or training from the device to that telecom edge and then taking it to the cloud. So that's for the starters where, and I can deep dive as we go further.
Sure. Yeah, go on. I can see that you've come off mute there, Stewart, so I'll hand over to you.
I've politely waited. I think the thing is that the use cases are emerging, clearly. I think it's very easy to get sucked into a need to invest in a kind of forecast demand. But, Vodafone, the customers we talk to who are making those kind of initial first steps are customers who've already got a kind of, what we used to call a chatbot, or they've got, analytics engines, or they've got remote access apps, or whatever it might be. And those platforms and the compute that supports them have been positioned in the network to serve a certain latency requirement, a customer, experience expectation that predates GPU as a service and edge architectures. Generally speaking, I'm talking about the majority here. So they already know that their customer is comfortable with 20 milliseconds or 30 milliseconds or whatever it might be. I think the emerging use cases, arguably some of it is sort of re-emerging. If you think of the metaverse, and now we're talking about gen gaming, it's like, okay, I feel like I've seen this before, but I think there's emerging use cases where you do need sub 5 or sub 10. There is also a model for that because, edge compute and distributed edge compute isn't something new. It's just AI, up to now, AI hasn't been the use case necessarily for it. It's been mostly industrial, it's been medical, it's been trading, it's been all those kind of good things. So, and what we're trying to pinpoint as an organization is where exactly Gen AI and sort of edge inference are going to have the biggest impact. And flip side, ensuring that we don't overcapitalize on a market and neglect our traditional sort of core content delivery network requirements. And we've already seen some of that, if I'm honest. We're starting to see, load on private network interconnects being exceeded because, there hasn't been enough investment. Stuff's falling back onto public peering. Our content networks are being, in some cases, oversubscribed because there's been a lack of investment from our content creators. So there's this whole dynamic going on. And I always urge a little bit of restraint with these things. I think it's a very interesting and an emerging opportunity, but what exactly it means, that's what we're here to discuss. I don't think any of us probably have the answer yet.
And maybe I can just ask a follow-up on that, because I think the question of use cases is a really interesting one. And there's a whole range of different, as you say, use cases that have probably been around for 10 years or so, both on the consumer and the enterprise side, which we're seeing sort of rehashed with a bit more of a kind of generative AI spin on them today. And I'm really keen to understand maybe what are some of the areas that you're seeing a bit more customer demand in today, or maybe hypothesis areas you expect to see more customer demand in imminently. And that could be certain areas on the consumer side, more like the kind of generative gaming piece that you mentioned there, or it could be certain enterprise verticals. Are there particular kind of big bets you'd have on this space at the moment?
So we've seen a steady increase in voice streaming naturally because people are interacting with their agent using the voice rather than contextual, text strings, and that's driven a certain amount of traffic increases, and that's just going to continue. I think that's just going to become the norm. You talk to your agent, you don't type to your agent. I think gaming is an obvious one, but I also serve European military organizations and NGOs and central government and so on as well. And they've got really interesting use cases in terms of public health and safety, clearly in terms of defense, in terms of cyber defense in particular. But and from a very, very personal point of view, edge AI for us brings the kind of self-healing nature of our investments in our core infrastructure to the edge as well, because that's, to an extent, a lot of the tool sets that were developed to keep our core network running to the best of its ability and to kind of predict overload and so on has really been inward looking. It's been, serving our needs to keep our network running. Now we're starting to look outwards and say, okay, what's the impact of that change I've just made? What, the intent that drives the way we provision a point of presence? What's the impact on the application? And so bringing a level of inference to the edge and observability to the edge, and letting CX be the guiding factor behind the way we run our core. These are new things for us, but it's a big area for us. As I said before we joined this session, I've canvassed so many people internally, got so many different opinions. Everyone's investing, everyone has the same objective, but it's we're right at the peak of that hype cycle, I think so.
Yeah, for sure. And maybe Tomek, if I can bring you in on this one, because you've obviously got a slightly different viewpoint. You're more on the high performance colocation side, and you're also US focused as opposed to the focus on Europe. Does that tally with your kind of visibility of the market from a use case standpoint of inferencing workloads, or are you seeing different trends?
No, I think I feel like everything Stewart's saying is spot on, and I'm really enjoying the conversation here. But I think these trends are kind of ubiquitous, probably globally. But I think I think the scale at which it's happening in the US is probably a bit bigger, because we entered the AI revolution as typically America does, like haphazardly with just pedal to the metal. We've really run the infrastructure ragged, and now we're trying to play catch up. But outside of that, the scale aspect, I think it's a pretty similar situation.
Great. And kind of anyone feel free to chime in on this one, but are we, is this a rerun of some of the benefits that we were claiming that enterprises were seeking 10 years ago when we first started talking about kind of edge computing? Are we still thinking about this as latency being the critical factor that's pushing workloads towards the edge and pushing investment within kind of last mile infrastructure, or are there other areas maybe around sovereignty or control or access to the hardware that are actually bigger drivers towards more a distributed computing network? And I can see, Majed, you've come off mute there.
Yeah, I think this is the core of what we need to discuss today, because there are three things. There is something that is being brought up again after 10 years of hyping. I don't see this as good or bad, because in technology, that's always the case. You hype up something when it's required investment for it, etc. It doesn't mean it dies over time. It means it gets positioned in a more pragmatic place. And I think latency is getting positioned in a more pragmatic place, mainly with consumer-driven applications. For enterprise-driven applications, it's more around sovereignty and security. We're seeing AI being a big help for enterprises, and there's a big focus on how do you share your data, how do you leverage AI without exposing your information, etc. So that's one other element. But I think the bigger element that's pushing edge AI is not the use case itself, it's the feasibility of service providers to deliver the use case. And by that I mean this is not a nice to have edge AI, it's a must to have for use cases to run. One example is what Stewart mentioned around traffic. The back end and the backbone of the network will collapse if every single voice command, every single interaction with AI goes back to a centralized location. So it is actually bandwidth saving requirement. Another requirement is more around power and cooling, and Tomek definitely has his position is exactly at the right time today, which is at one point there's no way to leverage GPUs sitting in a big data center and keep scaling and scaling and scaling. The power, the cooling, and everything will reach a threshold. By pushing it to the edge, you're able to use more of an ASIC approach, which is basically application specific compute capabilities for specific applications at the edge that are more power efficient. They're smaller footprint. They can be hosted in locations that a big data center would not be able to accommodate, etc. So in my view, yes, there is a big focus on use cases, and yes, latency was hyped, and I think it's getting more or less pragmatic. Security and sovereignty, we can talk a lot about regulated entities and the work with health and government and all of those things. But I think the bigger play here is the need for the edge comes from the feasibility of driving use cases in the future at a mass scale and requiring that distribution. That's why we call it more of a distributed AI rather than like pushing it to a very specific point in the network.
Definitely makes sense. And Nikhil, I can see you're looking to come in here as well. So keen to hear your thoughts backing that up, but also maybe if we can kind of lead the conversation onto a little bit about what are some of the infrastructure upgrades that need to be made more on the connectivity side to enable this kind of distributed inferencing as well. But keen to hear any other thoughts on the previous conversation as well.
No, this is exactly where I was leading to. And the part where we were discussing about use cases, we are talking about distributed context. The permutation of use cases towards connectivity has broadened out. Like it has become very, very specific. The latency was always bread and butter for connectivity. That's what we were always selling. That was always about Wi-Fi generational use cases, connectivity towards the cloud. But the part where it has come up more elaborate of using these things along with the enterprises like medical, healthcare, where we have started talking not about the ultra low latency, start talking about privacy. And we are happy to say that there are things which can be on-prem. In 5 context, we have started talking about private 5G being deployed in bigger healthcare facilities where the things can be done locally. There's some of very important contexts which shouldn't go out, but the latency should stay very, very low. We have started talking very specifically in sub 10 milliseconds. I think Stewart was mentioning about the 5 milliseconds context in the factory safety environments, enterprises. We're talking about there's a huge momentum towards robots. The robots coming into enterprise or coming for the consumer grade. How is that infra going to be set up? And we are, again, like open for discussion, but a very, very specific infrastructure being deployed. The on-prem is available, but there are control loops. There is a robot-to-robot conversation happening in sort of connectivity, but also robot to the cloud going through various connectivity hops. We are talking about agentic flows. We are talking about call centers where there will be automated field calls, this complete audibility scenarios. So there are these permutations of low latency with something. Sometimes it's cost. Sometimes it's between handover between Wi-Fi and 5G environments. Specifically in like AR, VR sort of environments where the glasses someone is wearing them inside, but then goes out. So these permutations in terms of infra is something that is evolving with connectivity.
Nice. And maybe just on the kind of Vodafone perspective from you, Stewart, because obviously there's a bit of a narrative here around integration of different wireless networking technologies and kind of integration with the wider network. There's different, obviously, traffic patterns evolving. What's the kind of Vodafone narrative here, I guess, around supporting AI across those technologies?
Well, we originally launched edge compute as MEC, so multi-access edge compute, and the focus was on a combined proposition. We all felt that the business case for edge was going to be driven by advances in 5G and advances in other areas, and there was a kind of beneficial, kind of symbiotic relationship between a few different technologies that together would drive the business case for edge compute. I think all of those technologies that surrounded edge have kind of advanced in parallel, but also diverged somewhat. So now, we got 160 odd live private 5G deployments around the world. And the business cases we started with when we first, the first 5 or 10 of those, totally different to the ones for the 160th and beyond. Not just financially, but of course, there has been a significant drop in the cost to serve those use cases with edge routers that have compute built in with much lower cost of RAN, with availability of industrial spectrum, with regulation, NIS2 driving people to make those factory environments intelligent. But I think a lot of the edge use cases, I would say the majority of the edge use cases we see within industrial for mobile endpoints. So that's where 5G is kind of knitting everything together. For fixed endpoints, yeah, it's just traditional networking, to be honest. But where there's a robot moving across a factory, hopping between WAP or in outdoor areas, or kilometers of factory, that's an obvious one that we are seeing a very linear, edge to 5G kind of growth curve. The two area up, but everywhere else, it's more like static interference. It's kind of hard to read. So.
And Majed, I'm keen to bring you on a maybe slightly adjacent area, which is there's been a lot of talk about, I guess, increased interdependence between data center sites and edge computing locations, and to an extent with customer premises as well. With AI, as we look at RAG and we look at kind of fine tuning, etc. How do you guys see that narrative evolving? And I guess what's kind of Google's position in terms of leveraging different sites for different workloads? I mean, you touched on this earlier around the need for, using different sites for different workloads and managing those workloads across different infrastructures. Are you able to speak to that a little bit?
Yeah. I mean, it's easy to talk about it from a technology perspective. I mean, we can talk about the advancements in federated AI learning, where areas around like you can push a model that has been pre-trained into an edge location, and then it gets retrained based on the context of that location. It's important also to look at the API-driven context awareness, being able to know that this edge is specific for that location, for that type of customers, etc. But I think what's more important to tackle, and what we are hopefully going to tackle in the coming couple of years, is more around the financial part of it. Like, who is putting the money down for that infrastructure at the edge to be able to cater for all these use cases? And I think we've learned a lot from the initial 5G world of pushing Mac, as Stewart mentioned, but also we've learned a lot from all the other projects that we have been doing around private clouds and edge computing and others. And the idea here is more around collaboration between a hyperscaler and a telco provider, where someone is offering the infrastructure, the other is offering the location and the connectivity, and being able to leverage both internal use cases. I mean, Stewart also mentioned the idea of like AI being a driving force for autonomous networks and network performance and operations. So that could be an internal use case for a telco, but then in that same location, it can be exposed for an external use case. So that leveraging of infrastructure for several use cases, one coming from the hyperscaler to their customers, one coming from the telcos to their customers, and one coming from their telcos to their own internal users, makes it more efficient, enables us to do that. The biggest challenge would always also be the ability to keep things in sync, because ultimately, if you keep an edge running autonomously for a decent period of time, it gets its own ideas of how the AI world runs. It becomes a species of itself, as Darwin would say, from a species perspective. So the idea is to keep the sync, but keep it at a proper periods where you're not pushing costs too much or confusing contexts too much. So it is a challenge across all the three things that I mentioned: the technology of offering edge, the technology of syncing, but also the financial part of how we bring this together.
Great.
Yeah, I love that. And I think this is the collaboration opportunity, isn't it? Because hyperscalers are brilliant at building data centers at scale, and telcos are brilliant at building compute at the edge at scale that's completely distributed. And we, the relationship with Vodafone and Google is well documented. But this is where a collaboration is going to be key here. And I think to Majed's point, someone's got to pay for it. That's the other point, right? There's got to be a customer at the end of this who's willing to pay more for a slightly faster response, or a use case that justifies it. But we bring content and we cache content on the edge of our network today anyway for the Netflixes and the Akamais and the Metas of this world. Why can't we cache responses? Why can't we cache inference and compute at that same network edge? The relationships are there. It's industrialized. To me, it feels like the conversation we're having now is almost like a CDN 2.0 conversation. Like, what else can we cache at the edge of our network? Who do we do it for, and who funds it, and who builds it? Those are the difficult questions, but I think the architecture feels fairly clean cut to me.
Super interesting. And maybe one final question from me, and we've only got around 7 minutes left. So if anyone in the audience has any questions, do put them in the chat and we'll try and get to a couple of those at the end of the session. But just one more from me before that. And I'd like to direct this your way, Tomek, if that's all right, because I think what you touched on there is a really interesting point around who are going to be the entities that actually commercialize AI innovation with enterprises. And keen to hear, Tomek, from your experience, how the kind of companies that are really looking to procure high-performance co-location infrastructure from yourselves has evolved over the kind of 10 years or so that you've been providing that kind of infrastructure, and how you think that relates to wider industry trends around who the companies will be that really commercialize the forefront of AI innovation.
It's interesting. I was just literally thinking about that, kind of thinking about what Stewart was saying again. Content delivery network, things like that. There's a tremendous amount of movement right now around that. And I think, Stewart, your intuition is serving you well, because a lot of these things are happening here in real time. And the folks that are, I'm trying to not get in trouble here because I'm under NDA, but the folks that are responsible for the CDNs in the US are very much the next wave of enterprise infrastructure procurement, I guess you would say. So in the beginning, you had your kind of your training wave, and we had the kind of the inference infrastructure wave that has kind of evolved, I would say, to something workable and usable. But I think the content delivery network wave, which is really brass tacks kind of AI use cases, both consumer and commercial, coming to market. I see this happen in real time. It's going to hit Q1 of next year. So we're right kind of at that moment, at that breaking point where things are going to really change significantly. And it's really the folks that are kind of, some of them really the old classic players in the CDN space. And again, Stewart, you named a bunch of them. They're the ones that, from as far as what I see, they're the ones that are really footing the bill, because they're going to be first in line to I guess, reap the benefits of the infrastructure. And we believe that there is a fundamental change in the economy that's coming. And a lot of people question, well, is there really value in AI and in inference workloads? And from where I sit, I feel like the people within the ecosystem here are convinced, and they are tooling up to deliver this change very rapidly. I mean, it's going to, as soon as, people wake up after New Year's, I think they're going to start feeling these impacts. But the financial burden is really being led by those folks, the key players in content, in the content delivery network space, because they're certainly much better at it than the OpenAIs and the Anthropics of the world. It's an interesting thing from our perspective, sitting in the data center. You have these kind of monolithic companies that kind of sprang out of nowhere, right? You have OpenAI, you have Anthropic, you have Crusoe, CoreWeave, but their core competency isn't really getting the services to the people that use them. Their core competency is something totally different, and they've really showed how lacking they are in that space. So again, kind of the old guard of the content delivery network space has had to pick up the slack to make sure that all this stuff works.
And stop paying. That's the other thing, isn't it? Peering used to be free, right? And I think that's the other. You know, I'm totally with you, Tomek. I think this is the dynamic, definitely.
Okay, we have a couple of minutes for questions from the chat, so let's try and rattle through a couple of them. First one, I'll direct to you, Majed, if that's all right, which is how impactful is the egress costing from a decision-making standpoint when deciding between cloud to private infrastructure?
Well, in the world of AI, we learned that you have to extrapolate for the future. It's not the current impact, it's the impact we see once things start scaling. And we definitely see that this is one of the factors. Power and space are going to be also big factors. I mean, you've seen countries adjusting their whole economy towards hosting big data centers because they know that the power and the space is going to be an important asset. But egress is definitely going to be one of the things required, especially if service providers and network providers are stepping into the game and they don't want to lose money by having a huge bandwidth going back and forth. So it will be an important element.
Great. And another quick question in the chat then, and maybe Nikhil, I'll come to you for this one. Which markets or verticals are expected to leverage edge AI inferencing capabilities, both in terms of deployment feasibility and in terms of business value or ROI?
I think edge makes a very good sense, especially like I think Stewart mentioned in terms of metaverse he was saying, but I would say more in terms of these smaller devices, the smaller AR, VR devices coming up, the wearables devices coming up. We hear all the time from OpenAI coming out with the smaller hardware. Like this is very much in where there's a new use case. It's where the enterprises will be ready to deploy these edge servers. There will be less of deployments in terms of compute available on device. So that's one part where I would say it's right in coming in for now.
Great, and then let's squeeze in one last question. So we've gone through three, and maybe Stewart, I'll get your opinion on this one first. The question is, what are the network requirements in terms of latency, bandwidth, jitter, and frame loss for AI inference edge data centers? Can you put some numbers to that broad question, or does it really depend?
I'm not going to quote was, but I think it does depend on the use case. And we used to make the distinction between low latency and ultra low latency. Those are probably two stats worth focusing on, and it's really 10 or 5 milliseconds. And the use case, the cost basically rapidly increases as you go towards 5 from 10, because you're potentially building infrastructure as a service on-prem as opposed to building it at the network edge, and you're making a different set of investments. So it comes back to who's going to pay. If someone's willing to pay you for 5 milliseconds, charge them. I mean, that's it, isn't it, really? And the use case is hard to predict. We've discussed enough of them. I think it's coming, isn't it? So.
Okay.
And if I can get a quick second, Joe, I think to add on what Stewart just said, it also depends like which subcategory we can define in terms of millisecond latency. Also, we can define which categories will definitely need this 1 to 10 millisecond latency, which can still evolve more like 10 to 20 or 20 to 40. The class cases, the newer use cases coming up, this robots walking, and what sort of conversation they will need in the factory floors where there's high RF interference. So yes, it's a permutation of what we are looking at.
Okay. Unfortunately, guys, we are out of time, but hopefully everyone watching on found that a really insightful session. I definitely really enjoyed the discussion, and would like to thank all of the panelists for your contributions. Thanks, everyone.
Thank you.
Thanks, Joe. Cheers.